Alrighty, now we're ready to start in on Chapter 11. And many of you will be excited to know that the hardest math in Chapter 11 is going to be 4 times 2. So there'll be a lot less math here in this chapter. Earlier in this year, we talked about chemical changes, and that a chemical change involves changing substances into new things. So that's really another name for a chemical reaction, is a chemical change, where one or more of the reactants will change into one or more of our products. In a chemical equation, it's really a chemist's way to, in a really shorthand notation, give you as much information as possible about what's happening in this chemical reaction. We're going to learn about the things that we start with, which we're going to call reactants, the things we end with, which we'll call products. We'll talk about what states those reactants and products are in. Are they solids or liquids or gases? And we'll have talking about balancing the equation. So all of these things will be expressed in a chemical equation. The first part of writing a chemical equation is coming up with what we call the word equations, which really just is in words, a simple way to say what's happening. Reactants are always written on the left, products always written on the right, and they are separated with an arrow. And if we're going to read the arrow out loud, we would use the word yields, gives, reacts to produce. So the very simplest kind of a chemical equation is a word equation that shows reactants and products with an arrow separating them. One of the advantages of using a word equation is it simplifies how you would describe a reaction. So we could say here, looking at this big old rusty truck, we would say that iron reacts with oxygen to produce iron 3 oxide, which is rust. But a simpler way and much quicker way to write that is to write that iron plus oxygen yields iron 3 oxide. So as we saw in the previous slide, in a word equation, we write the names of the reactants on the left, and we separate them with a plus sign. Products go on the right, and we also separate them by plus signs. We don't use a plus sign on the product side over here because there is only one product. Here's another example of a word equation, something you may have been familiar with, using hydrogen peroxide. Hydrogen peroxide, it decomposes to form water and oxygen gas. But a word equation would show hydrogen peroxide as a reactant with a yield arrow, then water plus oxygen. We can simplify that word equation even more into what we call a chemical equation. It is the representation of the chemical reaction, but instead of using words, it uses formulas. So we use the formulas for everything. So the rusting word equation we used earlier, where we said iron plus oxygen reacts to yield iron 3 oxide. Everything's still there, but it's a much simpler way to go. If you're only showing the formulas of reactants and products, we call that a skeleton equation. The writing of a skeleton equation is really just the first step in writing the complete chemical equation. So this right here we would consider to be the skeleton equation, but not the complete picture. We can add more information in our skeleton equation by giving us the physical state of each thing. We'll use S for a solid, L for liquid, G for gas, and AQ for something that is dissolved in water. And we've looked at that AQ before. Oftentimes in a chemical reaction, a catalyst is added to the reaction. A catalyst is something that will speed up the reaction, but it is not used in the reaction. So a catalyst is neither a reactant nor a product. So we don't write its formula in the same way. We don't write it on the left as a reactant. We don't write it on the right as a product. We write it right here over the arrow. So in this case, the hydrogen peroxide, which is right here, we say decomposes to make water and oxygen gas with the use of MnO2 as a catalyst. This last slide just kind of summarizes all of the different symbols we've talked about here. There's an additional one of heat. Sometimes it's written with a little triangle over the arrow, indicating that heat was supplied to the reaction, really to kind of get it started and keep it going. So all of the different symbols, and these would make sure we all get all of these into your notes.